In this video, I'm milling an arcade handheld body from Billet aluminum. It's tough, light, sleek, and sexy, and the most challenging part of creating the ultimate arcader handheld. Stay tuned. If you're following the Arkader handheld series, you may recall we milled and polished some brass buttons on the Pocket NC. This was the first step in creating the ultimate all-metal Arkader 3 handheld. Today we're continuing that work and sharing the next big hurdle in accomplishing this, and that's the milled billet aluminum body. Now this part is intimidating for several reasons. One, the walls on the body are thin, in some areas as thin as 0.6 millimeters. That puts an emphasis on precision of the milling, finishing, and polishing operations. Two, its shape has lots of off-axis slopes and it'll require some creative tool paths to reduce machine tooling. Three, running these on a 3-axis CNC will require either a fixture or precision ground billet or a flip jig or registration pins or all of the above. Four, with limited time to do this work, failing on this part would really be a setback and that would suck. So I need to prevent that as much as possible. But this wasn't going to get done by worrying about it, so I got started planning on how to overcome these things. Since 1 and 4 are non-issues that only add pressure, I focused on 2 and 3, making some great tool paths that won't take hours and a good flip strategy to complement the operations. To do that, I jumped into Fusion 360 to build the manufacturing strategy. My strategy was to define a model to represent the precision milled billet stock. This would identify my mount points, which are 4 M4 bolts that would thread directly into the bed on the Makerdreams Evo-One CNC. The stock would be positioned in the Fusion assembly, perfectly centered on the handheld's body. The solid body of the stock would then be used in the manufacturing setups as the origin for all operations. And if everything goes well, the flip jig would be perfect and we'll be off to the races. Since I'm milling against a precision ground billet, I decided to go with the exact stock height. This would reduce unnecessary material removal, but at the same time require some precision planning. As this will be mounted directly to the CNC platform, no wasteboard, any through cuts need to be inverted, which just means that they need to be milled out on the top side rather than milling through the bottom of the billet. Easy enough. My strategy was to remove a majority of the material while the billet was solid. This would mean removing the body cavity material before milling the outside. The best place for the tabs would be on the top rim of the body, which has a 3 millimeter depth that's parallel to the Z-axis, which would make it easier to mill and finish. Since I can't do through cuts, the first operation is to contour cut on the outside of the body. Limiting the depth to 3 millimeters and adding tabs on the geometry tab, I used a 1/4 inch 3-flute flat end mill with full engagement and running a conservative with a 10th thou depth of cut around 15 inches per minute. Next, a 3D adaptive was used to rough out the body cavity. Again, using a 1/4 inch 3-flute flat end mill, this time with a 25 thou depth of cut with a 100 thou optimal load at 65 inches per minute. After the roughing operation, I decided the fastest approach to finish the internal face would be a high-speed contour with 10 thou depth of cut. As the Arkader's custom circuit board fits snugly into this enclosure, the tolerances need to be on the mark. And to do that, we need a 1/8 inch 3-flute flat end mill. This would allow for the mill to get into all the small fillets of the inner cavity. You know, while making this body can seem complicated, the circuit board is really where all the magic happens. Now's a good time to mention that this video is sponsored by Altium Designer. If you're interested in building complex products like the Arkader 3 handheld, Altium Designer can make this process easy to engineer and accomplish with confidence. If you haven't taken the chance to download your free copy and see what you're missing, I've put links in the description. With Altium Designer, creating these prototypes is a piece of cake. The efficient workspace has some of the best features in the industry. Through all the phases of your development, you'll be empowered to do your best work as you grow into some of its more advanced capabilities. The link below will allow you a free trial version of the software, so you can check it out and see what enterprise class ECAD feels like. And now back to the project. With the inside operations complete, I created another setup to handle the outside orientation. Again, using the stock solid body and center point as a reference for operations. For the outside, I start with the same 3D adaptive to rough out the body's shape, using the same 1/4 inch 3-flute flat end mill with a 25 thou depth of cut and 100 thou optimal load at 65 inches per minute. To keep things simple, I'll run the same contour path as I did internally at a 10 thou depth of cut, but this time I'll use a 1/4 inch 3-flute ball end mill to give it a smoother finish on the step downs. After the finish pass, I'll run an operation that takes me down to the tabs previously milled on the first side. For that, I use a contour cut and a 1/4 inch 3-flute flat end mill at full engagement with a 10 thou depth of cut at 15 inches per minute. This should leave 8 1.5 millimeter tabs, holding the body in place without having to perform a through cut. With the operation set up, they were post-processed and ran on the Makerdreams Evo-One CNC. The stock was prepared with 4 pilot holes and mounted to the platform. The machine was zeroed to the absolute center of the billet, and the internal operations were ran. These feeds and speeds are conservative enough not to require air or lubricant. Running the first operation established the tabs, so I won't need to mill a through cut on the second side. Next step was running the 3D adaptive to clear out the body cavity. This took the most amount of time to remove all that material, running almost 2 hours. Next, the internal contour was ran to clean it all up. With the internal cavity complete, it was time to flip the stock and start on the body outside. Running the 3D adaptive roughed out the general shape of the body, preparing it for the finishing pass of the contour operation. Remember, the contour operation was ran with a 1/4-inch ball end mill, which left a nice smooth yet satin finish on the body. It was starting to look like a success. The next operation was to run the cutout contour with a 1/4-inch flat end mill to reveal the tabs from the earlier operations. Then, finally, using a 1mm 2-flute end mill, I cut out the air vents in the body, finishing off the main milling operations. And like that, the most difficult and rewarding milestone of this objective was accomplished, or so I thought. Next, it was time to cut the tabs and remove the body from the stock. Using a rotary cutting tool, I cut the 8 tabs cleanly, then used a hand file to remove any tool marks. To remove all the tooling marks, I sand it using a rough, medium, then fine-grade foam sanding blocks. This was just to rough the finish down to be more manageable. With the brushed finished, you could see all the ports that still need to be milled out, and we'll get to that soon. A little more work with fine, ultra, and microfine foam sanding blocks brought it closer to a satin finish. At this point, I used my drill press and Mother's aluminum polish to buff it up to a near mirror finish. This is where I stopped to perform the remaining milling work. In Fusion 360, I designed a rigid fixture to hold the body. Side note, I did another video on milling these off-axis ports, and while this is similar, I beefed everything up to be more rigid to mill the aluminum body. The fixture was 3D printed using a professional-grade Rhino filament from Matter Hackers. It's much stronger, more rigid, and prints really nice. With the fixture ready, I married the body to the interface, then mounted it to the base. For these operations, I used my heavily modified Shapeoko for height clearance and to mill the various ports on the body. In Fusion 360, I created pocket cut operations to mill the ports at various angles that the fixture needs to hold the body. Once the operations were complete, I post-processed them out to the machine and performed each of them carefully to ensure the alignment and placement of the 7 ports. If you'd like to see more details on this process, I've got a video that covers the fixture and off-axis milling technique that I use here. With the ports and holes all milled, next I needed to decouple the interface from the body, and to do that I used a heat gun to heat the body and expand and release the body interface. To finish the body, I wet sand the body using soapy water and 1000 grit sandpaper. I spent a lot of time here working out any surface imperfections to bring in the surface to a near perfect state. This was a lengthy and laborious process that really can't be rushed. In the future, I may try to find a way to machine sand the body using a special fixture or sanding wheels. If you have any experience or ideas about that, I'd love to hear about them. Please leave them in the comments below. With the sanding complete, it was time to again polish it up to a mirror finish. Using Mother's aluminum polish, I prepped the buffing cone, then prepped the body, and using light pressure, letting the cone do all the work, I worked the body in a consistent direction and pattern. And when finished, I buffed the body up with a microfiber towel, bringing it to a mirror-like shine that I was going for. Now this finish is beautiful, but at the same time it's delicate. It collects fingerprints and scratches very easy. To prevent abrasion and improve its durability, I'll be coating this with a Cerakote clear finish. It's designed to improve the longevity and durability of these types of polished billet aluminum parts. Now with the body finished, we've got some more work to do. Assemble the circuit board and speaker subassembly, and in the next installment we'll be finishing this up and showcasing this version as it compares to the clear and black Cerakote editions. That's going to do it for today. Hopefully you found this video interesting, informative, maybe both. I'll place all the products I used in the video in the description below to make it easy for you to find. If you purchase through my affiliate links, it costs the same and helps support the channel. If you're new here, hit the subscribe button and ring that notification bell. It'll help keep you in the know when the videos are released on the channel. If you like this particular video, give it a big thumbs up. It lets me know you care. In the meantime, I hope you're having a great holiday season, so be safe, have fun, and I'll see you next time. Hey, if you like the video, please subscribe to the channel. It's how we're building the community. Also allow me to bring better content. Also check me out on these other social networks. There's lots of cool stuff there too.